H2 is the smallest molecule in the universe, but just how small is it really? Welcome to H2Minutes. H2 is 50 picometers wide. A picometer is 1/1,000,000th of a meter. To grasp how small that is, let's do a little experiment. I need you to pull out a single strand of hair. Well, I might need some assistance. Okay, so look at your hair. You can fit approximately 3 million H2 molecules across the width of a single strand of hair. Sometimes when we say we have 1 part per million of H2 in a solution, it doesn't sound like very much. But if you had 1 ppm of dissolved H2 in a 16-ounce bottle of water like this one, you would approximately have 150 quintillion H2 molecules. That is 150 followed by 18 zeros. To break it down even further, there's approximately 2 quintillion H2 molecules in a teaspoon of hydrogen water measuring at 1 ppm. If we could turn all those H2 molecules from this teaspoon into pennies, we could approximately fill up 333,000 Dallas Cowboy stadiums. Man, if I had a penny for every H2 molecule that I drank. So why is all of this important? Because H2 is neutral and is so small, it can get anywhere it wants to in your body. No area is off limits for H2. H2 can pass the blood-brain barrier, the placenta barrier, and any other barrier that's in your body. This is important because 20% of the oxygen we breathe goes directly to our brains. 2 to 4% of all the oxygen we breathe turns into free radicals, which makes our brains very susceptible to oxidative stress. Things like glucose, sodium, alcohol, nicotine, and some drugs can get through to our brains. But many antioxidants and vitamins cannot. But H2 can. This makes H2 a highly promising remedy for oxidative stress in the brain. H2 can even get into subcellular compartments and reduce oxidative stress in the mitochondria and nucleus. It can even help to protect our DNA and RNA. I hope you all learned something new in this episode. And that's your dose of H2 in 2 minutes.